All right, everyone. I want to thank everybody for joining me today. My name is Kris, and today we're going to be talking about digital forensics and reconstructing an attack on a modern web application. A little bit about me. I am the Chief Technology Officer and a co-founder of Critical Fault, a cybersecurity company based out of Oklahoma. I have been in IT for damn near 20 years, just almost there. Recently, I made the switch, well, not recently, several years ago, I made the switch from doing IT, working at an MSP, to switching over to being a developer for several years, which I realized I'm not a very good developer. I make a lot of mistakes, a lot of common mistakes, and these mistakes presented vulnerabilities in the software that I was writing. I had worked for several I worked as a freelance and for several different projects, and I was introducing vulnerabilities into the software I was writing. So I became obsessed. How do I fix these problems? How do I stop having these vulnerabilities inside of my own software? And so as I came up with solutions and did my research, I started sharing this information with the community. And that actually got me my first job in security, and it's been history ever since. Okay, so I have a picture of a kiwi up here. I need a safe word. Preferably a fruit. Does anybody have a safe word for me? Banana. We have banana. Okay, so the reason why I ask for a fruit safe word is I have a tendency to talk a little too fast, to get really excited. I am pushing forward real quick. If for any reason, if I'm talking too fast or not close enough to the mic, or you just want me to go back and cover it again, please yell out banana. Once. Just once. All right, well, we're going to go ahead and jump straight on into this. Okay, so there's some AV problems. We had to seriously reduce the resolution. So if we can't read something, I'll zoom in or just yell out banana, and I'll tell you what the screen says. But we're actually going to do a live demo. That's why we're running it this way. All right, well, let's do a quick crash course into digital forensics. There's a couple key pieces of terminology we need to go ahead and address, and some other pieces of understanding what is going on. So real quick, for those that don't know about the Verizon Data Breach Investigation Report, it comes out every year. It is an excellent report that talks about with companies that are willing to share their breaches, their incidences, the attempts to hack their organizations or just social engineer their way in, and they compile a huge listing of this information so we can better understand where the attacks are coming from. Now, what's very important here is that in the 2022 version of this report, that we saw that roughly 45% of all attacks were based on web applications. Now that can be trying to hack your way into the web application, that can be trying to use stolen credentials through a web application, but the vast majority of all attacks came through some sort of a web application. And so it's important to talk about, well, when an attack actually occurs, how do we get started? How do we understand what was affected? And so we do know when we're talking about hacking, the actual act of connecting to a system and sending payloads and trying to breach the system through some sort of technical means, the vast majority of all attacks are against web applications. This is wildly different than it was 5-10 years ago. But web applications, I'm convinced, is the next frontier of cybersecurity. It's the place where we need to be focusing. There was an excellent talk yesterday on setting up a AppSec program. That was a fantastic talk. If you haven't seen that one, definitely find David. He's here somewhere, and definitely have a conversation with David. Okay, a couple quick bits of terminology. So in digital forensics is the formal process of collecting evidence and storing it in a formal chain of custody to prove that that information was appropriately acquired and not mishandled at any point. Oftentimes, when we do present in court, we do have to be cross-examined, and we do have to show that the evidence is correct, that it is officially there, that it was acquired using industry best standards, that if somebody else were to do the exact same digital forensics examination, they'd come up with the same results. There's also what we call the chain of custody. This is very important. We need to prove that the evidence that we're presenting to court made it in its full entirety, that no bit of integrity could have been possibly misconfigured, deleted, changed, anything. Nothing should be modified when it comes to the chain of custody. Incident response, I love this slide. They're hiding under their folders. So incident response is different than digital forensics. Incident response is the act of responding to an incident while it's happening. It's mitigating the active threat. So the reason why I bring incident response in here is there's a lot of overlap, at least when an incident occurs. And we're going to talk a little bit about incident response and how incident response occasionally can derail later investigative efforts. So that's an important piece that we want to talk about. And then there's expert witness testimony. This is when somebody, like yourself, presents in court and they ask you all kinds of terrible, horrible questions and try to discredit you as a human. And you have to prove that you are worthy of being in the room. Okay, so we're going to do a live demo today. That's why the audio-visual is a little wonky, just to make sure that it all works. But this is a simplified example. The whole point of talking about modern web applications is they're not so simple. They don't exist on a single system. They don't exist in a single, their ecosystem's not shrunk down to a single piece. And so we're going to talk about what the modern web application development pipeline looks like. Now, you probably can't read everything on this page. That's the point. This is, I mean, we have continuous integration, so CI/CD going on. We have things being fetched from repos. We have a Slack component that is pulling in information. We have Docker. We have all kinds of things happening in AWS. This is one single application example. But a breach and an actual attack can occur anywhere within this framework. And just because you see the output of what actually occurred doesn't allow you to see the inception point, the origin of the attack. And oftentimes you have to work your way backwards. You know what went wrong, but you have to work your way backwards to figure out how did it happen. This is a little bit more of a simplified view. This is more the older view, the three-tier system, where you have the web servers, the application servers, and then the database servers behind the scenes. This is a little bit more of a traditional view. It's easy to understand, but all of this, everything that we see here, translates back into what we see here. It's just so many things are spread to serverless components or to other SaaS providers that may provide some piece of that puzzle. But technically speaking, it boils down to what we typically see here, where you have web servers, you have application logic servers, and then you have database servers. There's so much more that can happen, but that's the gist of what occurs. And in modern web applications, there's a ton of different tools that you're going to be expected to at least know how to work with them, how to investigate them, how to understand what is there. Again, we don't have to read every single piece in here. The point is, it is difficult. It is difficult to know where to get started. Where did the breach occur? Did it happen in Jira? And we have to work our way up through Jira. So there's a lot of different pieces. I added this slide just today after I listened to Nick's talk about doing phishing from SaaS providers using disguised invitations, so invitations to projects, invitations to the cloud providers and whatnot. That's excellent. And when you have attacks coming from this particular perspective, how do you even figure that out? Especially when you can spin up a tenant, do whatever the attack is, and spin it back down. How is an examiner able to figure that out, figure out that information? I also put, so the one on the left is proxies or VPNs, or just anytime server-side request forgery, where you let another system do the attack for you. So if that's the case, well, how do you determine where the real origin of that attack came from? And then finally on the right is databases. Oftentimes, and we're seeing this more increasingly, that when we do see the inception point, where we do see the attack actually occurred, that generally people think, oh, they dropped a file on the system, or they made modifications to the system. But nobody really ever seems to think about, well, could they have dropped a payload in the database? Could they be operating and living out of the database, which is a very real thing, especially with stored procedures, if you're in the SQL ecosystem. So there's a lot of ways to hide your tracks, and unfortunately, in the forensics examination process, we have to be able to look into, frankly, everything. And I will say the SaaS part is going to be by far the hardest. Okay, so anytime you're doing an examination, there's always some must-ask questions that are always going to be presented to you. The first one is always, how long will this take? That is always what people want to answer, or what you want. They want you to answer that information as quickly as possible. How long would this take? We did one not too long ago where I had to drive 6 hours to go pick up the server, do the chain of custody, and bring it back. And before I even returned back to our forensic lab, we were already getting questions. Hey, what did you find? What do you mean? I haven't even gotten to the lab to actually be able to unpack everything. But this is the norm. People want to know because sometimes whatever the breach may be may affect business. In this particular case, it was ransomware. And this particular satellite office was cut off from the main office until they figured out where the ransomware came from. So I had to get a report out as quickly as possible, but you don't want to rush the process and give bad information or incomplete information. But at the same time, the client is down, and frankly, it was a hospital. So meaning they couldn't deliver their services to the patients actually admitted to the hospital until we got our information in there, because they couldn't record or do anything because everybody uses electronic health records nowadays. The other question always is what happened? Well, we're going to talk about a lot of the different ways of getting there, what was affected, very important. Frankly, the FBI guys did a great job of explaining the slide for me just a few minutes ago. And of course, how did it happen? And then this is the question, it's a super dangerous question, how do we prevent this from happening? It's not really the forensic examiner's responsibility to provide that information. We're supposed to tell you what occurred. How did it occur? But oftentimes we get that question, well, how do I keep this from happening again? So we do have to give some general best advice. Generally, it's not rolled into the reports. It can be, but we can give industry recommendations for moving forward. Okay, so I did say incident response, digital forensics, there is a bit of overlap. Unfortunately, with incident response, there's a mad rush to fix whatever the issue is. Things are on fire. You're trying to get that situation under wraps as fast as possible. Oftentimes, this can be wiping systems, restoring things from backups, taking systems offline, who knows, rebooting systems. That's anytime that, as an examiner, if I need to preserve volatile evidence that's in a cache or that's in memory, how am I going to get that information back when the incident response guys ran by and rebooted everything? How am I going to do that? So unfortunately, the incident response is almost never perfect. It never goes right. And that's just the nature of the beast. So our job oftentimes is to work with incident response and provide guidance so that this information is preserved, that evidence isn't destroyed in the process. It's very important to have that open dialogue with your incident responders so that, I mean, I've been an incident responder. I've addressed lots of different issues, and I have even, in the past, realized that some evidence was destroyed in the process. Yeah, the client's back up and running, and this is the case. Anytime that you have a case like this is a recovery effort. You're trying to understand what exactly happened and make sense of what logs and evidence still exists. And again, this gets really hard to figure out what occurred, where did it start, and you have to suss out, is this traffic? Is what is occurring on the network based on the attackers? Did the attackers cause the activity that you're seeing? Was it incident response that caused? Usually they cause a huge amount of activity on a network, on a system, on different locations throughout the network. And so now you have to separate that out. Well, was it incident response that ended up making a change here? Or was it just regular, everyday user activity? We have to strip that information out to be able to focus in directly on where the attackers came in. And again, there are so many different places to start, especially on modern web applications. Okay, so we're actually going to do a live demo. That's why, again, the audio-visual setup. So we're going to get started. If you guys can't read this, I will zoom in or just read it out. But in short, so we're going to do a live demo on an application server that a new user has been created. The user name is Bob. He's the local admin. What's going on here? We need to figure out why did Bob appear, what is going on. And there's some other bits of information. So whoever became aware of this said, oh, that's weird. There's an executable program called program.exe running. And we have a PID, a process identifier of 9832, okay? Well, what is that? What's going on here? So generally, old school tool, netstat, just take a quick look, figure out, okay, let's find the PID. So we have 9832 over there. So we have this PID, and we're able to see different information, and we can see that 9832 is connected to a IP ending in .33 on port 7777. So this is a good indicator that something interesting is going on. We also know that NetBIOS and other common Windows tools are sitting there listening to different traffic. So we already have some information of maybe how somebody was beginning their breach efforts. Okay, so the person who noticed what was going on also took the time to just fire up Process Explorer to take a quick look. And, okay, we need to figure out where's this program.exe. So they can open up the file location. Uh-oh, it's on the C drive. That's definitely a problem. I'm sure somebody knows why, but we're going to get to that here in a moment. Okay, so here before we switch to the live demo, we're going to talk about a couple common tools. This is not a tools talk. There are tools that we use, such as forensic imaging, but I'm not here to tell you exactly which tool to use. That's for you to decide, especially as you're working, you build your own digital forensics department, or you work with others. So it's important to know what tools that they used. That should be in the report. But again, the tool serves a purpose. We're not here to tell you which one is the best one. So anytime that we are doing an examination, oftentimes the most common thing that we need to do is to do some sort of forensic imaging. This is the process where we capture all the data on a storage device, all of it, including unallocated space. Very important that we get that space. Think about it. If an attacker's on a system and they're writing files to disk, and then they want to clean up their tracks, and they delete their records, and then they move on. So at this point, if we did an image, and we only imaged every single file on the system that's still there in the master file table record, or however, whatever file system that you're using, if we look at it that way, then we can only see the files that still exist. But what about the deleted information? What about the information in the slack space or unallocated space? What other information can we go and find? So we do need to do a full capture of the storage, and frankly, that's a lot of data. I mean, we're talking about images that are the exact same size as the actual storage device. So if you have a 500 gig SSD, you have a 500 gig image that comes out of it. Yes, there are compression methods out there. That is a bit of a problem that when you try to argue in court, yes, I used a compressed method. You have to prove that it worked and it worked correctly, but still, that compression only works so well. Another piece that we're going to be talking about is the timeline view. So the timeline view pulls from a ton of different sources. So let's say I get an image, and I take that image, and I want to process the timeline. So Windows is a pretty easy one to understand, that there's going to be a lot of information that's going to be specific on that system. So Windows, as we know, it has date modified, date created, last accessed. These information that we can use to build a timeline to understand. But that's just for files. We also have the event logs. We have any kind of other operating system logs or application logs that may be on the system. And we also have artifacts. This is, for example, when you launch an application from a GUI, that there's going to be information that Explorer will automatically create behind the scenes. There's going to be information inside the registry. There's going to be tons of information all over the place that we can come back and examine and understand exactly what happened, because all of these artifacts get created. But this isn't the only place we're going to be looking. Today, it is. You know, it's more of a simplified view, but we also need to go look at what other systems were touched in the process. Did they pass through a firewall? Was there a proxy involved? Is the proxy logging? Did they trigger any canary tokens? Did we have extra information? Does the SIM have the answers that we're looking for? These are other places that we go and we try to find out the information of, well, what exactly happened and how did it happen? Hex editor doesn't, again, I don't care which one that you guys use, but a hex editor can examine, I mean, we have a JSON file opened here, and we're looking at it through a hex editor view, where I can actually look at the contents. I can see the information that is stored inside the sectors on the hard drive and be able to understand exactly what they're doing. And while extremely rare, I have seen plenty of times where an an attacker will use some sort of bitwise operation and will shift the columns, or will make some tiny change to a header. So it's not as obvious what the file is, where or why it's there. They may even do some sort of bitwise encryption using just simple XOR that would make it even harder to understand exactly what we're reading. So hex editor is one of your best friends, and once we have this information, we can come back and process and understand what's going on. File carving. I do like this. This is the image that you see here is a sector map. So it basically gives me, a cluster map, a little bit different. But it is all the storage information that we see graphically on an SSD. It's 232 gigs for those that, I'm sure it's hard to read up there. But there's a ton of information here. Even though this drive was wiped, this drive was quick wiped. For those that don't know, with a quick wipe, if we're talking in the Windows ecosystem, only wipes the first 3,000 sectors and the last 3,000 sectors. All the data is still there. So I can use a file carve. So you'll actually go to the system, you'll go to the drive, and it looks, thank you, and it looks blank. It looks like nothing is there. Thank you. So you won't be able to see it because it's not in the master file table record if we're working in the Windows ecosystem. But the data is still there. We can use file carving to actually do a sector-by-sector scan and figure out, based on the information that's there, maybe the file headers, and be able to understand where the files exist, how many sectors those files are. Of course, when you talk about fragmentation, this gets even weirder. So that's why those file table records are so important. Also, file carving is a way that we can use to prove if disks are actually cleansed. So what we saw was a quick wipe a moment ago. This is a full wipe. There's still technically information on there. We still have a couple pieces written to some of those sectors, such as master file table records that you guys can see below, NTFS log files, just some basic information, but there's very little information inside a fully wiped drive. Now, there are some very interesting ways to do recovery processes on a fully wiped. Obviously, there are systems that do multiple passes, but that's not what we're here to talk about today. Some of our other more advanced tactics, sometimes we want to go look at page files, swap space, memory dumps. It's not on the slide here, but memory dumps are a gold mine. We can find so much. But what are the chances that there's going to be a memory dump at the same time that there's an intrusion? It's very low chance, but memory dumps have huge amounts of information that we can be able to pull from. So also, instead of just pulling from a memory dump, let's say the system is still live, it's still booted, it's still listening, application's still running. Well, we may want to do a live capture and be able to actually do our own memory dump, to be able to pull everything that's there, be able to grab what's in memory. It's very rare, but in some cases, you can even take that memory, you can freeze it with liquid nitrogen and take it away. It's a very delicate process, but you can actually capture the information that's still on the memory sticks and be able to pull that. We do oftentimes look at slack space and unallocated space, but these are for more sophisticated attackers. They're the ones that are trying to hide their tracks, or maybe hiding things in the inodes or the file IDs, depending on the system. You can hide information all over the place. And one of the places, especially on Windows systems, that seem to always be forgotten is if a full day passes, or it strikes 12, or depending on whenever you have your shadow copies configured. Oftentimes, by default, they just run at night. So you can pull information out of the shadow copies. And fortunately, most attackers seem to forget about shadow copies. They don't do anything to try to cleanse away the shadow copies. So you may not have the evidence directly on the disk, but it's all hiding in the shadow copy. Or maybe it's located in the backups, and you have to be able to mount the backups and be able to perform a full exhaustive search of that. And then finally, there's the report. This is the part that nobody likes doing. But this is where you have to come back, and you have to hit those must-answer questions. Your report is going to live beyond you. When you turn in the report to the client or to the company that you work for, when you give them the report, that information leaves you. You aren't going to be there to defend it. It's going to go in front of boards. It might even make its way in front of law enforcement. And I've had several reports that made it into the hands of the FBI. And at this point, you're not there. If you made a mistake in the report, it's going to reflect back on you. If you missed something, it's, again, going to reflect back on you. This is the perfect opportunity for you to really, it's almost like a little resume. You are creating a resume for yourself every time you generate one of these reports, because you want to be as accurate as possible and be able to provide the necessary guidance to an organization to be able to recover from that. Okay, so last couple slides, and then we're going to jump into the actual demonstration. So anti-forensics, these are pretty uncommon, with the exception of timestamps. I do see time stomping quite often, where an attacker will change the clock and then perform their actions and then change it back. So it does get a little confusing, especially when you're trying to build a timeline to understand exactly what happened. So timestamps, probably the most common. Stenography, this is the act of hiding information inside of other information. Most attackers don't have time to do something like this, but if they do, oftentimes they're using some very generic ways of doing that. They're going to find a tool that exists that maybe use, for example, least significant bit. So if you have an image and every pixel, let's use a bitmap as an example, every pixel has a byte of information that is configured for that. And in that byte, you can change the least significant bit, meaning instead of 255 for red, you can do 254 for red. And at that point, that we know that there's we can see that small change, and we can extract that information, be able to have a better understanding of exactly what they did. And unfortunately, fortunately I should say, attackers don't spend a whole lot of time trying to hide their steps, especially using these anti-forensic processes. What we do see on occasion are encryption on payloads. That's a pretty common piece, that they're trying to hide their communication. They're trying to not alert whatever XDR, AV, whatever acronym you want to throw out there. They're trying to fly under the radar, and so encryption does help with that process. But once it's on the system, unless we're talking about ransomware, very rarely is it the actual payloads or actual tools that get loaded on a system, do they get encrypted. Onion routing, so Tor, dark web, whatever you want to call it, that oftentimes we do see communication going through onion routing. That does make it more difficult to figure out the origin of the attack. And so it's just a piece that we need to be aware of. Overwriting data is an excellent way to hide your tracks. So we talked about deleting files. Well, it's actually better, instead of deleting files, of just overwrite them. Put some other information in there once you're done with them, and then we can't make sense of what you were doing. We can see the time, we can see the file IDs, we can see the timestamps, we can make sense of what's going on. On rare occasion, we also see program packers. So for example, taking an executable and hiding other information within that, you can package those up. So we do see that sometimes they're hidden in there, and you can do an examination of an executable and have a better understanding of what's going on. Memory droppers are hard to find, very hard to find. For those that are familiar with what happened with SolarWinds, there were memory droppers all over the place. This is how a lot of these attacks did occur. Not the initial attack. We're talking about the subsequent attacks. Once they actually had access, they used memory droppers to be able to pull tools into the environment, operate in memory, and then exit. And this is why volatile evidence needs to be preserved as much as possible. So if an incident responder comes by and reboots, it's gone. Sorry. Not a whole lot you can do then. Obfuscation is kind of like encryption, but it's just taking, I don't know, let's take a ASPX web shell, which we're actually going to look at here in a little bit. So that web shell, you can obfuscate it. And the whole point is just to make it harder to be able to understand, unpack what exactly occurred on that system and have a better understanding of what the payload is trying to do. And then digital signatures. This is a pretty common piece. We also saw this in SolarWinds, where once you have a payload on a system, once you have that executable, that you want it to fly under the radar. And one of the best ways of doing that nowadays, especially as we're getting better and better application protections, is to sign it. If you have access to the internal CA of the, as an attacker, if you have access to internal CA, you can use that information to sign your packages, to sign what you have and be able to hide your information. Okay, so we're going to attempt the demo gods here. So give me one sec. And yes, that was Mr. Bean. Okay, not a big deal. There's a notebook upstairs. There's actually two of them. Could you grab both of those, please? Yeah, yes, thank you. Okay, not a big deal. I just have a couple notes for myself. Well, we're doing an examination. I do have a couple spots I want us to look at. If we were doing a full examination, this would take us hours to days, and I really want to get to some of the hot spots as quickly as possible. All right, so we have a tool up here. This is a graphical tool. There's a ton of tools that live in the Windows or the Linux ecosystems that oftentimes we'll use. I'm using a graphical tool for your benefits so we can have a better understanding of exactly what's happening. But oftentimes we do use a lot of more advanced tools. I just wanted you to be able to see this information. So we're going to create a case, and we're going to call it RVAsec. It doesn't matter. We can provide other information in here. And in this particular tool, we've created a case. So now what we're going to do is we're going to add a device. And we already have an image file. Remember how we had the system that Bob was created? We're going to go load that location. Okay. I might want to go back one sec. For those looking at this is a Windows 2016 server that has a piece of software on it called GFI Archiver. GFI Archiver has a known vulnerability on this system right now. It's actually been around since 2018, but the GFI software was written this year. So this is a known problem. It has yet to be patched. So if you are using GFI Archiver, I'd recommend that you don't. All right, so we have a full disk image that includes the partitioning information. So we do have a boot partition. Very simple. Windows does that for you automatically. And then we have the partition with data. So we're only going to load one of the partitions. I could mount the entire image, but I want to focus on the second partition with about 80 gigabytes of information. Okay. So now that we actually have it loaded, we have our image loaded into our software, we can start doing some analysis. Now, oftentimes, we run ingestion modules. So for those familiar with sleuthkit or autopsy, that they generally call them ingestion modules. And what I mean by this is that, for example, we may want to come through and index every single file on the system and be able to understand where keywords are. So it allows us to do keyword searches. There's a ton of other tools, especially the timeline. It does take a while to be able to produce that timeline. So what we are going to do, we are going to go ahead and run a user activity, which is basically a timeline view. Different tools call it different things, but they're generally performing the same actions. So what we have here, and I knew this was going to be a problem on the smaller resolution, is I can't get to the button, but that's okay. So this is going to look for operating system artifacts, internet artifacts. It's going to pull a bunch of information, and these are just common spots in Windows where you would want to look on a system that you think that some sort of crime, some sort of intrusion has occurred, that you want to be able to pull this information. It's going to give a ton more information on the system. So we're not going to configure anything. It's already set to defaults. And what we're going to do is just a quick scan. So we're not going to do a deep, in-depth scan on this. Thank you. All right. Just takes a moment. Perfect. Okay, so these were common spots. Now, we are looking in common places for common problems that we might be able to find. So we're looking in the recycle bin, we're looking in downloads, we're looking in the event log. There's so many other places we could be looking at, but a quick examination, for example, that client, the hospital that was wanting to know how long are they going to be down, this is a way that I can start feeding them information faster. They don't like the answer, I don't know, we're investigating. So there are ways to shortcut some of your pieces. All right, so what we have here is a timeline of events. And what we're going to do is we have some different events here. And so we have some failed logons. We have login using, let's take a look at this one. Now this one may be a little hard to read. We have logins using explicit credentials. Does anybody know what we're talking about when we're using explicit credentials? The F word? No, explicit credentials are generally any time that we have a service with credentials set, that service needs to run with those very explicit credentials. You'll also see this with scripts. You'll see this with scheduled tasks. Again, we're in the Windows ecosystem. So you're going to see these spots where we're going to have very specific events that are coming through. All right. So we can also jump to, Give me one moment. Okay, we've got a lot of activity going on here. Okay, so here we are. We're in the timeline view. And what we have is we see that there is a couple of weird files getting created. So we have this reverse.aspx. We have access to the GFI directory software that is a part of the archiver service. We have, so it looks like there's some activity going on in here. So, and we have reverse ASPX. We have the reverse ASPX in the recycle bin. So let's go take a look. Let's go have a look at the recycle bin. So now what we have here is we have the ability to actually examine what's inside the image. Now this does process off the MFT. So if you don't have an MFT, this particular process doesn't work and you need to do file carving. But since the MFT is preserved and hopefully not too much data is deleted, we can look at some more of the common locations. So the MFT is still aware of deleted items in the recycle bin, and it includes the file IDs. So there's two different types of file IDs here. The ones that start in I will tell you generally where the file is. The ones that start in R will tell you what's inside the file. So they always end in the same file ID. So 2G, 2V48. So there's 2G, 2V48. And so we have the one that starts with an I and one that starts with an R. So if we load the R, well, there's some sort of a file here that says you've been pwned. So something's going on here. So what we can do is we can start examining, seeing what other information is in here. And we can work our way down. So there's a couple you've been pwned. So it looks like what they were trying to do is upload some different files just to see if it even worked. We can see that there's an exe here, and there's a lot of information in here. So let's do an extraction. Let's see if we can have a better idea of what's going on in here. Now, when you find exes or any kind of like ELF file or binary file that you may want to have a better understanding, a DLL, understanding what exactly they're doing, sometimes we do have to run reverse engineering processes. That one's a hard one in court, to be able to tell people exactly what you did. So much harder. But we do see that there's some calls going on in here. There's some different information, and there's this weird little one. For those that can't read what it says payload. So there's an exe on the system that has something that's referencing a payload. We can see it's calling the kernel32.dll. There's some weird things going in here. And without doing a full, like launching Geerda and being able to do a full reverse engineering, which we definitely do not have time for, what we can also look at is this one ends in 87. Here's the corresponding file ID for 87, and we can extract that to make sense of it. C.program.exe. Okay, so we're starting to be able to piece together what exactly is happening here. Okay, so we also have these ASPX files. So I want to go down and look at the ASPX files. Okay, well, that looks like a web shell to me. If we work our way down, that one is blank, and I think this one's, yeah, that's our big one. All right, so there's a lot going on in here. There's even shellcode going on in here. So the shellcode, for those that don't know, shellcode is a fun and handy way of being able to write code written in a very specific format that computers will be able to understand if you're able to process the hex code. So that's a very brief, simplified explanation of what shellcode is. But yes, we're seeing an ASPX file. It's loading the kernel32. We see that there's information going on, and then it's processing this big shellcode. So that is definitely concerning. So let's do some other couple pieces. We know Bob is an administrator. At least Bob looks like an administrator. But sometimes when you're doing your examination, you don't know that. Maybe the responder didn't identify that. And there are ways for us to be able to figure that out, for be able to actually understand what exactly occurred. So one of those pieces is for us to load the registry. Again, Windows ecosystem. It's a little easier on Linux. But we can load this up, and we can start working our way through the SAM registry hive. And inside of that, we can start working our way down. We've got a couple locations that I do want to talk about. So we do have accounts, we have users, and we have some users. So we have some different information. We also have the names of the users. And so we have these weird numbers here, letters and numbers here. For those that don't know, that's just simple hexadecimal. And so what we can do is we can look at administrator. So we can just load up our calculator, and we will make that a little smaller. And we're going to type in 500. Okay, so 500. This may be a little hard to read, but in hex, 500 is 1F4. There is 1F4. So we know the administrator, which always has the SID of, specifically the ID of 500, and we can see that 1F4 is right here. So what we can also do is we can look at Bob. So Bob has 1002. So 1002. We can see that's 3EA. So we have 3EA right there. We also have a couple others. There is one here that is sitting that doesn't quite, it's not a default built-in account or anything, called the GFI directory account, directory admin. And we can see that one has a ID of 1,000. So if we put in 1,000, which is a very simple way of converting that to hex, we see 3E8. We have 3E8 there. So we know that there's some other information. We can even see the flags that are set on the account, whether that if the password needs to be changed, whether the password never expires. We can see a bunch of information like that. So there's other spots that we can go and look in. Let's see. All right, so let's look at built-in. Let's look at aliases, and then let's go down to members. Okay, so now we have an SID here. And so this is an SID for a group, a built-in group. And we can see that there's some accounts that are added to this group. We can see 1F4 is in the group. And we can actually work our way through and be able to understand exactly what that group is, but this is the default local admins group on the system. So we have 1F4 is in that account, or excuse me, in that group. We have 3E8, which we confirmed was the GFI directory admin, and we also have 3EA on that system as well, or excuse me, in that group. So this is information that we know is valuable to us. So we know we can confirm that they're actually a part of this. So another piece that I do like to do, we're going to launch that guy again, and we're going to load the, I believe it was, yes. All right. We're going to work our way down. So we're running the system hive, the registry hive. We're gonna load up system. So when you have an active system and you are in the registry hives, you're gonna see current control set. That's how it will read. But when the system powers down, that it gets converted and it will say control set, and whatever your latest control set will be the highest number. And so we can walk through that. We can have a better understanding on the control set, and we jump into services. And so the reason why I wanted to jump in here, this is one of the highlights. So as we're doing an examination, we can see what's going on inside the services. And what I'm trying to figure out, the key reason I'm looking in here is because I saw that explicit credentials were used. So there's a couple different spots I'll look. I'll look for scripts, I'll look for scheduled tasks, and I'll look for services. These are places where oftentimes specific credentials are set. And what we're talking about here is, just so people know what we're talking about, is this is my own system, and we have the log on as. And right now, we are looking for a log on as that is different than all the others. Now, this doesn't match what we're seeing in our image. We're looking in here. And so we want to have a better understanding of what's happening. And we know that the GFI software is here. We know the GFI software has a vulnerability. And so we can jump down, and we can actually find the service account information for the GFI software. And here we have it. We have it right here. Now, this is going to be a little hard to read, but we have the GFI directory services that manages. We can see the username that the system, that the service is using. We have GFI directory admin, and we have this little line right here that says C, program files, GFI directory. You guys can read. But we have this information here. Does anybody see a problem here? Does anybody have a quick giveaway of what may be going on here and what exactly the attack, one part of the attack, the actual attack chain that has occurred? I'm going to jump to another one and see if it gives it away. We'll jump to Chrome. Here's that image path again. Does anybody notice something different? It's really hard to see. This has double quotes. GFI does not. GFI does not have double quotes. So if you're on a Windows system, Windows does this funny little thing that when it tries to call an executable from some location, when it's instructed to run that system, it's going to try and work its way down. If it's not quoted, it will try to work its way down and try to figure out exactly where that is. And it will have problems anytime it hits a space. This is where things go haywire. And so by default, what the system will do is it will try to run It will look for the C drive, it will look for program, but it won't look for program files initially. It will look for program. So it will look for a folder named program, it will look for an executable named program, such as program.exe, and it will just automatically run it. So we know that that program.exe was sitting on the C drive. We know it was deleted, and so we know that it's very likely what the attack in this particular case is that the attacker, once they gained further access to the system, was able to be able to modify a service. Well, really, just find a service that was running with unquoted paths and be able to drop a program.exe, which is a payload, on that system and just wait for the service account to run, which would essentially, once that service actually ran, it would load with whatever credentials were stored. It would load program.exe instead because it was trying to load this, but we were able to intercept it. The attacker was able to make this happen, and we were able to figure out exactly what they were trying to accomplish. So this is one spot that we can look in. So there's a couple other pieces, and we're running a little short on time. So we are going to jump down to, looks like 3:45. Okay, there we go. So we have more activity going on in here. So we have inet pub, we have some logs. It looks like they were accessing the logs for IIS, that different activities occurring. We also have explicit credentials, again, where people are logging in. There's several places. Oh, we can even see what accounts they were using. We see that the GFI directory admin was logging in. That's a little bit of alarming. Why would that account be doing an interactive logon onto a Windows system? There's no reason for that. It's a service account. It shouldn't be doing that. So this is giving us extra information. And so we can see the logs. So let's actually jump to the logs. We are a little short on time, so I will make it brief. We can follow the logs, have a better understanding. Again, this all provided information from the timeline. Again, a lot of tools that we haven't been able to address today, but that's okay. So we have the log files. We have a virtual directory right here. So W3 Service 1 is what we have. And so if we load this guy up, we have 2 log files. And that's fine. So the dates, I know it's probably pretty hard to read, but that has 22/04/07. So that's April 7th of 2022. We also have a log file for 22/04/08, so the following day. So let's start at the oldest one, at the oldest piece in the log. And we can see that there appears to be some extra activity here. What we can do is right now we're looking at a hex editor view. Let's switch to a text view so we can have a better understanding of what is exactly in here. And we'll give that just a moment to finish processing. These logs, now where we're loading an IIS log, I still may be needing to go look at the proxy logs. I may need to look in the SIM. So what we have in here is a ton of information. We can see all kinds of bits in here. And what I want to do is, so we can see there's active connections to the archiver software, which is a part of the GFI archiver piece. We're going to scroll down, and just here in the middle, and we see there's connections to the archiver, introduction.htm, default.htm, and we can see where the connections are coming from, what port they're talking to, and we can see the user agent. Does anybody notice anything weird about that user agent? Did anybody recognize that one? That's a directory busting utility. So if you have a bad attacker who just uses tools configured as default, that oftentimes you're going to get user agents that are going to just identify what the tool is that they're running. In this case, it's FerrixBuster, which is a way of busting and figuring out different directories on the system. So we have a ton of activity of FerrixBuster all over the place. And to wrap this up, let's jump to the very bottom. And so we have some other information in here. We can see that there's connections going to Archiver, Telerik, Web UI, Web Resource, and we can see that they're post requests. A post request is when you send data to a web server. Instead of asking for data, you're sending data. So we see these requests, and we can see the user agent in here again is Python. Oh, that's weird. Why is Python communicating with our web server? We can see the pwn.txt that we saw earlier. We can see the reverse.aspx information in here. And the thing that happened just before that is we had a post request from, to the archiver, Telerik UI, web resource, and we can follow this information back, and we can see it came from this IP. And again, this is highly simplified. It is generally not anywhere near this easy. This IP address could be masked, it could be proxied, who knows. We know it ran through Python, and we know that it was posted with a HTTP status of 200. The very next thing that they did is they made a request to this reverse.aspx. Sounds to me like they uploaded it right here, which in fact they did. This application is vulnerable to a arbitrary file upload. So essentially they uploaded this reverse.aspx, which is a web shell. Then they ran the web shell by calling on that web shell to actually be able to process, and we were able to come in and be able to understand that. So I'm getting the STFU flag, that's okay. So I'm gonna step away here. If you guys have any questions, please just join me out in the hallway here in a moment. And thank you so much.